Good morning. Now we proceed this part, acceleration. How we get acceleration in differentiation. So instantaneous acceleration, the symbol is small letter a, is a rate of change of instantaneous velocity with respect to time. So remember, sometimes the question didn't mention acceleration straight away. They will say, find the rate of change of velocity with respect to time. You need to know actually this one refer to acceleration. So how to get acceleration? If you want to find acceleration from the velocity, you need to do differentiation. So previously, what we know is displacement, we differentiate, we can get velocity. So to get acceleration, you can differentiate velocity, then you can get acceleration. Or if the question give you S displacement, want to find the A, then what you need to do? You need to do 2 times differentiation. So that's why we can have the formula. First one, A equals to dv dt, if in terms of velocity. Or we can say in terms of displacement, A will be equals to second derivative of displacement. So this one, if the graph function for the v is a linear function, when you plot velocity time, so the graph look like this, meaning that the gradient of the graph refer to acceleration because the gradient is dv dt. Okay, and then uniform acceleration, meaning that we have constant acceleration, meaning that the velocity is not changing. And then if the function v is a quadratic function like this, when we plot the velocity time graph, so we can say if you have the dv dt greater than 0, meaning that this one is positive acceleration, meaning that the velocity is increasing. And then at this part, dv dt equals 0, meaning that we can have the maximum velocity at here. And then when going down here, dv dt less than 0, meaning that this one is deceleration, meaning that the velocity is decreasing. So now look at next page. This example, a particle move along a straight line. So again, they give you the velocity formula. And then find initial acceleration. When you see initial, meaning that t equals to 0. When t equals to 0 is the a value. So now given v, so velocity, how to get the acceleration? You just differentiate your velocity. So a equals to dv dt. So just differentiate like usual. 2 bring down time 1. So you have 2. T copy. Power 2 minus 1 become power 1. Differentiate negative 3t. You have negative 3. So this is the a that you have, the formula. So just substitute t equals to 0 and you get the a equals minus 3. Question B. Find the acceleration when t equals 2. So just substitute t equals 2 inside the a, then you can get the a equals to 1. Minimum velocity. Remember when you see maximum or minimum, then you need to find d over dt something equals to 0. This one is velocity, so dv dt equals 0. dv dt actually is a, meaning that a is equals to 0 and at these cases. So just substitute a equals 0, then go to solve and get the t equals to 3 over 2. So need to find minimum velocity when t equals to 3 over 2. So just substitute 3 over 2, put inside the velocity formula, then you get the minimum velocity. So this one will be your homework, page 193, 194.